minus z minus 2 minus I equals to zw plus z plus iw plus I, which gives us wz plus w times 2 plus I minus zw minus iw equal to z plus 2 plus I plus z plus I. I kept this z and this I, they're down here, but these ones moved over to there. And I moved the w terms all to one side. That's what I did. So you want to isolate w, it's our game. I'm trying to isolate w. So what we then got is w is equal to, looks like 2z. I count 2 z's. I count plus 2. And I got 2 i's. It's good. Whoa. Whoa. Really? I mean, I don't disagree. I was really hoping for an honest-to-goodness, genuine fractional linear transformation, but starting to feel like I'm starting to feel like I got a 2w, and so this algebra I'm doing is a little bit unsatisfying, because that gives me w is equal to z plus 1. Sam put you up to this, didn't he? I feel like this is I feel Sam's presence in his absence.
Well, I guess it makes sense because you're just taking every point here and translating it there.
Yes. So what did I say at the start of all this? A Mobius transformation is composed with rotations, magnifications, translations, and inversions. We have just worked very, very hard to translate this up to here, which amounts to shifting the center here to there, which is a translation by 1 plus I. Well, this is actually a variance. This is actually fortunate that this happened, because we can learn a lesson from this, right? There's a danger that, once you learn how to use a certain power tool, you want to use it on everything, right? Like, I don't know. Once you get like you get a pneumatic gun with 1,000 psi, whatever, and to put your roof on, and then like the next week your wife asks you to hang a picture or something, so you get it out inside. But what you should be doing, of course, is going and getting a little hammer and going, because that's what this is. Like, we do not need the cross ratio for this problem.
So is it because
we have used, yes.
Minus I to 1, you did them in the same order? Is that why?
It's because it's got the same size, the same diameter or radius, however you want to look at it, and the same orientation. If we had taken this and taken these points, went right like that, 90 degrees, we would have need this times I or something.
What do you mean by rotating? Choose 3 different points there, each offset by 1 degree on the circle?
Yeah.
So different points, because that was the question I was going to ask. If you chose different points, would it have the same result?
No, you get a different transformation.
Because it wants to also turn.
Right. And, yeah. You know what, though, guys? You can mix stuff together. We could take the thing I've erased, which was a solution that put 0 on the top and pi on the bottom. You could take that and take that solution to Laplace's equation, which is up here, and you can move it over to here. You could have an equation which puts 0 on here and pi down here, by just translating our other solution appropriately. But there's more. You can easily create solutions which put, you can make a solution on the half plane which puts different constants along different parts of it by like a relatively benign trick using arguments. I'll show you that Monday most likely. But I don't show you all tricks. I just try to show you most of my tricks focus either on circles or half planes. That's kind of where I'm drawing the line.
When you say the tricks are benign, you always fail at doing them.
I always fail at what?
Doing them.
Doing the tricks. Yes.
At least in class, for the first time.
Yeah. I never teach well at the 12 o'clock hour is what it boils down to, but except for linear, and let's just face it, linear is easy. Yeah. It's hard to mess up linear, like I forget how to add and scalar multiply, like it's not likely to happen.
Today after class, we were saying that we feel like we would have understood so much more about linear if we had taken abstract first. Like it just seems like a really special case of that. You know what I mean?
Linear seems like a really special case of abstract.
Yeah.
It makes me happy to hear you say that, yes.
So we should learn about the complex plane first, and then we can learn about the real
Well,
plane later.
yes, I mean, Dr. Wang argues we should start with topology, and then you should do calculus, because before you can understand continuity, you understand open and closed, and you can't do limits without topology. You should do topology first, then calculus. But I would say topology, no, I don't mean linear algebra first, then topology. I don't know. These are all silly discussions. Yeah.
Just mix everything together for 4 years.
Well, that is Asian mathematics. Is that there's not in this idea we have algebra, and then we have pre-calculus, and we've got calculus, like this demarcation of mathematics into subdisciplines. Like this is not how it's done in Asian high schools typically. We have math 1, math 2,
I think
3.
we have math for numbers, and then we have math for geometry. But basically, if the math class teacher will go up and talk about whatever you want.
Right. Yeah. I mean, that's what looking at my wife's curriculum from Hong Kong, you know, they did like a little bit of number theory, a little bit of linear algebra, a little bit of a lot of different things in her advanced level math.
As long as they number about it, they can talk about it.
Mhm.
I feel like that would get more people interested in math.
I think so.
I had no idea what any of this was. In high school, I just knew about, like, calculus was the farthest thing I ever heard of.
Right.
Or knew of.
Yeah, I don't think calculus as the end point of math education in high school is a good thing. It should be more broad.
Yeah, and if you say proofs, everyone just thinks, like, triangle proofs and
Yeah, and why are we putting all of our effort into geometric proofs that no one cares about? That doesn't even illustrate methods of proof.
No.
And we do these like, it's not
Like
proofs,
columns
columns and
and
Yeah.
I'm thinking 305 with Sprano, and you argue the opposite.
yeah. Well, you know, Dr. Sprano's not right about everything, so I'll talk to him later. No, I know what you mean. What I'm trying to say is, in geometry, the things you're trying to prove are so obvious that it's frustrating to try to prove them. And then in a class like this, oftentimes you're trying to prove things that are not obvious, right? Well, it's a mixture. Some things you're trying to prove are obvious, and you guys basically say, it's true. Don't ask me to explain it, you know? I'm talking about abstract at the moment, sorry. Complex, the proofs are, for the most part, somewhere in between. I mean, some things are not obvious, right? Like, prove that the hyperbolic exponential's hyperbolic differentiable. You know, that's kind of weird and out there for you guys. I don't think you have any kind of intuition about that, right? You just have to follow the theorem and do it, yeah? I don't know.
That's more learning after you know.
Yeah. But I agree. We should, you know what? I don't think it should be that there's a standard curriculum. I think that math teachers in high school should be free to be themselves and to express the kind of mathematics they're most interested in. And that principals of high schools should hire people with undergraduate math degrees who actually know some mathematics. That, to me, would be a good solution. Not a standardized curriculum, a standardization of people expressing passion in mathematics in high school. Their own individual mathematical passion. That would be useful because that would excite students about math, not dogmatic adherence to some core curriculum or something like that.
So the problem is not that they need a standardized test to judge the amount of students. And if
Yeah.
someone really like something, the students don't do well on the standardized test.
Yeah, it's only
I don't
getting worse.
understand why,
too.
I don't understand why they would want you to do well on standardized tests.
Standardized tests do not
No.
measure how much you know.
But the problem with the standardized test is it sounds good and everything, right? Like when George Bush proposed this No Child Left Behind, it made some sense because of the abuses of the teachers' unions over the years to me. But the way it's been implemented is horrible because people know what's on the test in advance, and the tests aren't testing excellence. They're testing, does it meet the lowest common denominator of education, right? Instead of like writing tests, the teachers should have no idea what's going to be on the test before it happens. It shouldn't be possible to teach to the test. You should try to teach to excellence. And what happens on the test should not be known in advance, and it should be like just, wow, that test from this year was crazy. How are we going to adapt so our students can be ready for that next year? It should be more like that. What I'm describing is, the kind of exams which are in Hong Kong that decide whether or not you can go to the next level of high school and so
I mean,
forth.
that's the same. We have
Yeah.
the same form.
But then it would be more whether you understand it, not whether you can decide between 4 choices, which is the right answer.
Right, right.
It should be open-ended whole.
Well,
It's a lot of great.
I do have this to tell you. You may not. Have you taken the subject theory yet? Yeah, because that's a multiple choice. So like, I took the subject physics. That's the first one I took when I was undergraduate, and it was the first time I ever took a multiple choice test, and I had the feeling all of my multiple choice test gamemanship was irrelevant. Doesn't help a inkling. At least that's my experience with the math subject theory. Like, it's created by mathematicians who are completely disinterested in your ability to game multiple choice tests and deliberately design it
That's what I heard.
that you can't.
Taking it next month.
It's nasty.
I'm very excited.
That's good.
I'm going through the entire book. I'm in Calc 1 right now.
Ah, excellent.
I've read everything.
Yeah,
It's nice to go back.
I like helping students with that sometimes. It gives me a chance to gloat. Remember when I said you need to know such and so forth, and you're like, I don't need to know that. You're not going to put it on the test. That's on there. Everything I ever said like that, it's all on that test.
Great.
But anyway, I don't teach Calc 1 anyway, so it's a moot point. All right.